Welcome everyone, this is my printed circuit board design report for FOSSEE's Autumn Internship 2026. The design that I have chosen is an STM32F4VE, an advanced microcontroller board with an STM32F407VE6 IC microcontroller unit, which you can see right there in both screen and the rotating one. Okay, let me show my project. Let's open eSIM application. The version that I'm using is eSIM 2.5. Now let us open the project folder by double clicking it and opening the schematic file. We're using the schema page file, and this is where I have created all the circuits and placed some images of the STM32F4VE board, which I have in real life. I showed you in the beginning of the video, and also a couple of pictures of the layers and some silk screen layers. So when we run the ERC, we get 0 errors and 1 on 3 warnings. By the way, this error is when I use the label instead of power tools. Like for ground and 3.3, I have used wire labels. And this does not make any difference in manufacturing and don't create any error when making the PCB. So let us exclude all 4 and we have 0 errors in the electrical rule check box. This is the IC that I am using, which is F4VE7VE6. It is a high-speed microcontroller IC, and we have a couple of connectors, a very big connectors also. And in the right side, I have some oscillators, small connectors, switches, and more connectors. In the bottom, I have a SD card reader, a micro USB port, switches, and a CR12 battery with some LEDs also. As you can see, I have pasted some silk screen layers and the ERC and DRC images. Let's go to the PCB design by clicking the icon. And this is what we are using. I'm using a KiCad's version 6 application. It is inbuilt in eSIM. And I'm using JLCB's base model PCB for the rules. So I have made 4 layers in the PCB. Front uses the ground port. The second layer is using the ground port as well. The third layer uses the 3.3 volt port, and fourth layer, it is the back, uses also the ground. This is the microcontroller. So now let me hide all the other layers and show the front layer. And as you can see, this is the front layer with all the routings that I have made. Now let us see the second layer, which is a ground floor also. Now third layer, this is a 3.3 volt port, and this is the fourth layer, which is the back layer of the PCB. So let us run the DRC design rule check, and we have 0 errors, which is a very good sign. Now let us go and turn to the 3D model by clicking Alt and 3. So this is the model that I have made, and the 3D model is also imported from the Snap EDA website, and I have put all the components in place, and this is the final version of the PCB in 3D model. I have chosen the black color for replicating the exact color, which is the STM board. And I also have added the custom silk screen in the front and back layer. For example, I have added Sanjay, my name, in the board with STM logos and, of course, FOSSEE's logo. Okay, let me show you the footprints that I am using for the project. These are the footprints that I'm using, and all those are imported from Snap EDA website. And these are the footprints and symbols that I'm using. It's also imported from the Snap EDA website. Here are all the 3D models, symbols, and footprints that I am using. And also there are the custom silk screen images, as you can see in the bottom. Thank you for watching, and I hope I get selected into FOSSEE's Autumn Internship 2026.